Okay, so here's the second one. Actually, I'm going to change the mass of this to 6. Okay, so gun of mass 6 kilograms, fires a bullet at mass 40 grams. The muzzle velocity of the gun is 150 meters per second. Calculate the recoil velocity of the gun. Okay, so this is an explosion. Okay, think about it. It's an interaction. Okay, so the gun and the bullet are stationary. Bullet goes that way, gun goes back that way. Okay, so it's an explosion. So if it's an explosion, you're writing this down straight away. Principal conservation of momentum, and you're writing that down. Now, if it's an explosion, the initial velocities of both are 0. Okay, so at this stage, that'll be 0, that'll be 0. At this stage, you can write 0 equals. No problem. Okay, I think that's the best way to do it. Now, let's go through this. The gun is a mass of 6 kilograms, so we're going to call the gun M1. Okay, and the bullet has a mass of 40 grams, so we're going to call that M2. I put it down here. Okay, 0.04. Right? Change to kilograms. The muzzle velocity of the gun is 150 meters per second. Now, is that the velocity of the gun or the velocity of the bullet? Well, okay, but let's read. Calculate recoil velocity of the gun. So they're asking for the velocity of the gun. So this must be, and it makes sense, the muzzle velocity is the velocity of the bullet goes as it leaves. Okay, so that's the velocity of the bullet, which is 150. Okay, so we're ready to fill it in. So we have 4 variables here. We know 3 of them, so we're obviously in business. So we have 6 times V1, so that's the velocity of the gun. Okay, plus 0.04 times 150. Okay. Right, so the calculator, 0.04 multiplied by 150, so that's 6. So we have 6v plus 6, so minus 6 equals 6v. So the velocity of the gun is minus 1 meters per second. Okay, the minus indicates it's going the opposite direction, which it has to be. Okay, that would indicate from the question recoil. So okay, I would indicate there. Okay, you write v is minus 1 and say okay, the gun has a velocity minus 1 in the opposite direction to the bullet, just to be absolutely clear on what's going on. So there are the 2 core examples. Okay, first example where there's a collision. Second example where there was an explosion. But it's the same thing always. Always start with this. If it's an explosion or a decay, the left hand side will automatically be 0. Okay, but I think take it step by step. Right, that's the gist of it. Okay, principal conservation momentum, interactions, collisions, explosion, decays. Always write that and drive on from there.